Good day, Ma'am O. We are Group 10. We will present a project that we did, which is entitled Real-Time Arduino R4 Morse Code Decoder Translating Signals to Text. First is we're gonna show you what is the flow of our presentation. First is the introduction. Next is the project overview. After that is the hardware components and the software implementation. And next, we will demonstrate the project, and then we will conclude and tell the recommendation and the references that we did in order to accomplish this project. Now let's start into the introduction. First, the board that we'll be using is R4. The Arduino R4 is a powerful microcontroller board that can be used to create a variety of electronic projects, including a Morse code decoder. And next is what is Morse code? Morse code is a way of communicating using a series of dots and dashes to represent letters and signals. Here you can see is Morse code alphabet on what to tap or what to do in order to spell out the things or the word that you wanted to say. And next is the numbers, which is enlisted into 1 to 0. And next is whoa! Morse code only uses two symbols, which is dots and dashes, which makes it easy to transmit and receive even with simple technology, as you can see in the next PowerPoint. And now we're gonna tell you about the relevance of Morse code. Morse code is an efficient way to communicate in emergency situations, and also it is used for war back in the day. But up until now, Navy and Coast Guard still use signal lamps to communicate via Morse code.
So, for the project overview, next page please. Project statement is the purpose of this project is to develop a Morse code interpreter and decoder using Arduino R4. The device will be able to convert Morse code signals into English text and vice versa. This allows users to communicate with each other using Morse code without the need for specialized equipment. And for the objectives, we have three: hardware signal interpretation, software translation algorithm, and evaluation tech display. First is the hardware signal interpretation. We will develop a capable of accurately interpreting Morse code signal received via physical input mechanisms such as a button, and also enable user input from a computer to the hardware for Morse code translation. Second is software translation algorithm. We'll implement an algorithm on Arduino to convert Morse code patterns such as dots and dashes into corresponding alphanumeric characters. The third is evaluation text display. We'll integrate an output mechanism using Arduino R4 matrix to showcase the decoded text in real time.
So for the components, next page. So for the components, we will be using the Arduino Uno R4, which is the latest model that contains an LED matrix compared to older models which does not have an LED matrix. Aside from that, we'll also use a button configured at pin 8, buzzer at pin 2, and LED at pin 13. And also we will be using a resistor for the LED. So the button is used for user input, which accepts short or long presses. Then the LED provides a visualization, turning and staying lit up shortly or long in response to the button. Lastly, the buzzer indicates an error. Based on the user input, it will buzz if the system cannot identify the Morse code input. Next.
So in software implementation. So in the start of the software implementation, we first started creating our data sets. We begin in creating an array of Morse code using here in the table. We will reference these symbols in which we will indicate a dot or a hyphen or dashes for it, and this is for the Morse code number. Basically, we will be creating an array of Morse code for the numeric and alphabet, and we will reference the format that I shown earlier into the most Morse code here in the array. And basically, this is the 12 by 8 matrix of the Arduino R4. And yeah, so basically this is the 12 by 8 matrix of the Arduino R4. Sorry for the lag. And this will represent which uh, which LED will light up. If it indicates that it will be zero, it will be turned off, and if it's one, the value is one, it will turn on. So basically, you can lit them up manually by just putting the value one into the array, and the matrix will light up correspondingly. However, to make our code shorter, we will represent it as binary as shown here. So basically, in here, if you can notice, instead of trying to create a big matrix, we try to minimize it using binary method here. And if you can see, the 0 and 1 is just the same as in here, but in a shorter form. So let's try to make an example, like the number 0. The 1 will uh, lit up the binary, and the 0 will stay turned on, as you can see here in the symbol 0. And if we try to implement it, it will look like this. So we will be trying to do that on all the numeric value, as well as here in the letter value will be in A to Z. So that's our data sets. And then in our software programming, here our first method will be the add frame function. It's just a simple if else and for loop function that will identify the character. So here in the clear frame, as the name suggests, it will basically set all the matrix to zero, turning them off. And here in the setup, it's just a regular setup function from for the Arduino. It will just display or do what in here in the start of the program. And the next code will be the Morse code identifier. It will identify what Morse code will do or did using the user input, and also in the button if the series of if else uh, will loop. So here is the button. In the button Morse code, it will identify what Morse code will do for if the user press it or not. If the user press it longer, it will identify as a dash, and if it was pressed shorter, it will identify as a dot, and it will refer to the data set of the array of the Morse code after that. So here, lastly, is the simple if-else method that will display the binary value to the matrix of the Arduino. So here we will be demonstrating our program in this video.
For the conclusion, next page. The Morse code project made for Arduino shows how to change Morse code signals into letters and vice versa. Using Arduino Uno's R4 features and parts like LEDs, buttons, and the serial monitor, it creates a working system for understanding Morse code. Users can decode Morse code by pressing a button and encode text into Morse code using the serial monitor's keyboard. LED lights and sound help users learn and practice Morse code better, making it easier to understand. Next. And for the recommendation, the code can be adapted for use with the Arduino R3 by making minor adjustments to the components. Given the scarcity of Arduino R4, particularly in the Philippines, this circuit design can effectively function with the Arduino R3. However, leveraging its compatibility might involve incorporating an LCD display and a battery for improved portability and compactness.
So thank you guys for listening for our work. This is Group 3 and thank you.